Hello teacher, my name is Yanding, and let's start my presentation today. I still remember last time when we went to Quanwan's astronomical center to do the observation exercise, I had a chance to have a detailed looking up at the surface of the moon. Unlike what we could see every night in the sky, the surface of the moon is not very smooth, but many craters. The lunar craters are mainly due to the meteoric impact, and it makes me think about what it will be like about an impact in a much larger scale, and it leads to today's topic, the galaxy collisions. First, what is galaxy collision? It is actually one kind of the galaxy interaction. To be more exact, it is a gravitational interaction. When two galaxies are very close, the gravitational force of them will exert on each other and could be able to cause both galaxies to bend out of their shape. The result of this collision is either merging or passing through each other, which refers to near misses here. And it is actually a very common phenomenon. The galaxies are always included in a galaxy group or cluster. Comparing to the size of the galaxies themselves, the distance between galaxies is usually not very large within the same galaxy group or cluster, which makes the collision to be very common. And the galaxy collision is a part of galaxy formation and evolution process. Talking about how, it is mainly due to the force of gravity, and at the same time, the gas cloud inside each galaxy may be compressed and cause them to be collapsed under gravity of their own, and finally turn into a new star. It may lead to a burst of star formation in both the two galaxies. And the picture showing here is different type of galaxy collision. The galaxy collision type is mainly due to the type and size of the galaxies. When one large galaxy met a smaller one, the galaxy collision will happen, and the large galaxy will remain intact after the collision and merging. But the smaller one will be stripped apart and become part of the galaxy, the large galaxy. For example, the result of the collision of the spiral galaxy and dwarf galaxy is an enhanced spiral galaxy. And when two spiral galaxies met each other and have the collision, usually an elliptical galaxy is formed. The galaxy collision may take hundreds of millions of years, so we humans have no chance to witness the whole process of the collision. However, the computer simulation technology is very advanced today, and that the process could be simulated. The first graph is the approaching process. The relative velocity of the two galaxies is ranged from 100 kilometers per second to 1,000. And at the same time, the internal structure of the two galaxies have already changed, and the interaction is already began. And the collision starts when the two galaxies has interact with each other. At this time, although the core of the two galaxies don't meet each other, the deformation of galaxies already began and the matters are interchanged. And this diagram shows, in this diagram, the collision is almost finished. The shape, structure, and the internal components of the two galaxies are already changed. The mass ratio of the two galaxies also changed, and they are moving away from each other, and the collision is suspended. Whether they will meet each other again and have collision, it depended on their mass and relative velocity. As we can see from the picture, the bigger one is turned into a spiral shape after the collision. As we all know, our parent galaxy is Milky Way, so is it possible that our parent galaxy may be collided with each other, maybe with another galaxy? The answer is yes. And the other galaxy is our close spiral neighbor, Andromeda galaxy. The Andromeda galaxy is also known as M31, which is the nearest spiral neighbor of our galaxy, and the distance between them is about 780 km per second away from us. And it is also the largest galaxy in our local group. Talking about the collision, the two galaxies are approaching each other with a velocity of about 110 km per second, and they are predicted to have a collision in 4 billion years. Here's a video shows the process. And now the two galaxies are approaching each other and the collision happens. The internal structure and the shape are changed and the matters are interchanged. And then the gravitational force attracts them to have the second time of collision, and then the third time, and finally a new galaxy is formed. And do we need to worry about that if it's still allowed at that time? Actually, no. Yeah, it is because of the extremely tenuous distribution of the matter in galaxies. And however, the gas cloud will have a dramatic interaction with each other, as mentioned before. And a burst of star formation is happening. Although the stellar collision may not happen, there are two monster states in both the Milky Way and Andromeda, the two supermassive black holes. Due to the process of dynamic friction, the two giant black holes will converge near the center of the new galaxy. And during the converging process, the black holes transfer net energy to the less massive stars, and these stars are thrown into high radius orbit. And these supermassive black holes start to emit strong gravitational waves when they are near each other, and will be done until the merge is complete. At the same time, a luminous quasar or an active galaxy nucleus may be created by the gas taken up by the black holes. And at last, the remnant of the merger is a new galaxy, which is called the Milky-Meda. As a result of the collision of two spiral galaxies, the new galaxy is highly possible to be a giant elliptical galaxy, but it may also become a giant disk galaxy. And in a more far future, the remaining galaxy in the local group may also merge into this Milky-Meda, which is a new formation stage of our local group. In the future, if Earth is still there, the galaxy in the sky may be showing like this. It is very interesting, right? Okay, and that's all of my presentation today. Thank you very much.